Hello and welcome back to the second part of the crate modeling tutorial. In the first part we had a look at the Extrude tool and we also touched very briefly on the bridge tool. If you don't know what either of those two are, have a look at part one and that will give you a really nice introduction to those two techniques. Now in this particular tutorial we're going to be using those techniques on a primitive to create a game ready crate. Now the first step is to actually place the primitive on the grid. Now you'll notice that unlike the plane in the previous video, we don't have to remove any polygons, we don't have to optimize this from the ground up. It is already optimized. What I am going to do, however, is just scale this up. If I was modeling this as an environment artist, I wouldn't just be scaling it up willy-nilly. I'd have a series of measurements that I'd be using to determine how big this has to be in comparison to, say, a character or other environment clutter or other environment assets. But in this instance, we're just practicing the technique, we just want an awesome asset at the end of it, so we don't have to worry too much about scale or sizing. As long as everything that we model fits, we should be fine. So before we start, I want to touch on optimization. When you're an environment artist and you're given a project to work on, one of the first things that you will look at is what kind of constraints you have. Now to make this really simple, I'm going to use kind of the Nintendo DS and mobile games as an example. Mobile games in particular don't have access to the same hardware that consoles have and PC gamers have. So if I wanted to create a crate for those particular consoles or that particular platform, then we would essentially be done with the modeling. This would be all that we would need. All that we would need to do is take this forward and unwrap it and then apply material. Now in this tutorial we're going to be adding a little bit more detail and we're going to be aiming for kind of PS4, Xbox, PC kind of level of optimization. So as we go, I'll be talking about optimization a little bit more, but the first step in creating this crate is by changing the selection type to face and by selecting one of the faces. Now there are two ways of doing this. The first is by holding left click and dragging over that box. This will select all of the faces. Alternatively, you can press Ctrl Shift and A on your keyboard and this will select all of the faces for you. Now in the previous video we had a look at the Extrude tool. The shortcut key for that is Ctrl and E. There is a fundamental difference between the previous example and this example, and that is the number of faces that we have selected. So thickness will still work as it did. So we still get some activation from thickness, it still works. But offset, which is what we're going to do first, we're going to create our insets here to prepare for our depth extrude. As I increase that offset, you'll notice that nothing happens. And this is purely because we have keep faces together toggled as on here. Now this is a default option. Okay, we will be having a video in the future where we talk about how to change default options like this, but for now we're just going to turn it off and we're going to increase those offsets generally until we're happy with the size and the scale of those insets. Now if you want something that's maybe a little bit more realistic, then we don't want that offset to be too dramatic. We want to kind of have natural looking insets here. Whereas if you're kind of trying to create something that's maybe a little bit more stylized, maybe a little bit more wild style-like, WoW-like, those kinds of games, then all we need to do really to demonstrate that is increase that offset and just make that a little bit more dramatic. Okay. Now in this particular example I'm going to be choosing quite an extreme example and going for quite a stylized crate, but feel free to kind of have these gaps and have this inset as big or as small as you want it. So I'm going to close off this extrude by pressing W. If any of you have clicked off the model at this point, by the way, don't panic. You have two options. You can either Ctrl Z, which will bring you back to this selection, and if that doesn't work then we can actually select each of these individual middle sections by clicking and holding Shift and clicking the other middle sections. For the next step we are going to need all of these selected, so if you do have them selected then please keep them selected, don't deselect them. The next step is a depth extrude, so we want to actually create some depth into this model. Again we're going to press Ctrl E for extrude. This time we don't need to change any of the keep faces together options because none of the faces are touching. If these faces were touching then we may well have to keep faces together. We might have to turn that off in order to get the desired effect. But in this instance, all we need to do is just decrease thickness ever so slightly and press W to finish that off. And as you can see, this is beginning to look a lot more like a crate. But there's something missing. In most crates, we have some added geometry. And I'm going to refer to this as a slat because, if I'm honest, I don't really know what the actual name of it is called, but I'm going to call it a slat, and I apologize in advance if I call it a slat at any point. It's just a flip of the tongue, really. It's nothing I can really control, it just happens. So we have these extrudes now, and we have the depth, which is great. This is what we're looking for. But there is a question that you could ask yourself at this point, and that is, do I create that slat out of a separate primitive, another box, or do I model it into the crate itself? In this particular instance, we are going to model it out of a separate primitive. There may be certain occasions where you might want to keep the model as a whole. I've found in my experience that when you're unwrapping, which is a process we're going to go through later on, individual models are much easier to control unwraps for than very dense meshes that are totally kind of modeled together. An example of this is firearms. If you're modeling guns, a complicated gun, maybe an assault rifle or something like that, a lot of the assets, even though they're kind of pushed together to form the final asset, will be modeled separately. Things like the ammo clip will not be modeled necessarily from the body. Things like the butt of the gun, the back end, will not necessarily be modeled from the body. Things like the barrels, again, they might not necessarily be extruded straight from the body. Often these are just cylinders that have been kind of modeled and placed. In this instance, we're going to create a new primitive square. Now, before we do this, I want to introduce you to the hide and show functions. Now, for those of you who have never heard of this before, in most 3D packages, we can hide and show either the whole model or parts of the model. So let's have a look if I want to hide just part of the model. So let's say, for instance, I just wanted to hide these two polygons for whatever reason. Maybe I wanted to model something extruding from here. Maybe I wanted to model some detail in here that I can't extrude from the main poly here, and I need to actually be able to see inside the crate. In order to hide these, I have two options. I can either press Ctrl and H on my keyboard, or I can come up to Display, move down to Hide, and Hide Selection. In this instance, I'm going to press Ctrl H. Now, if I deselect those polys, you'll see that they don't exist anymore, except they do. They've just been hidden. Now, in order to get these back, we want to press Ctrl, Shift, and H. Alternatively, we can also come to the Display menu, come down to Show, and we can either click All Components or All. Either one of those will be fine. If for whatever reason Ctrl Alt H or Ctrl Shift H don't work, then you can always come in and click on All. But I actually want to hide the whole of this crate, just to begin with. In order to do that, I need to hold right click and change to object mode. I need to make sure that I've got that crate selected, and I'm just going to press Ctrl and H on my keyboard, and that's going to hide that for me. Now that that's hidden, I'm going to create a new primitive cube here. And I'm just going to move this on one axis just out of the way, and I'm going to press Ctrl Shift H, and that's going to bring my cube back, my crate body. The reason why I brought this back is because we now need to create a slat, and the easiest way of doing that is by using the crate as kind of a guide to how wide and thick and tall this needs to be. But before I model anything, you'll notice that there's a subtle difference between each of these objects. If I deselect this new primitive, see if you can see what happens. You might notice that the wireframe disappears. It's certainly much more obvious when we have the object selected. And when we deselect the object, other than the shading differences and the shadowing, we can't actually see that. I always find it's much easier to model with these wireframe options on. It makes it much easier to see the detail. It also makes it much easier to intersect objects because you're not having to guess how far in they are, or do they extrude beyond kind of a reasonable point of interest. So, for instance, does it extrude beyond this depth barrier? And to do that, we just need to turn wireframe on, and this is really simple. So above every viewport here, if if I just press spacebar and show you all four, you'll notice that you have exactly the same selection of controls in each of the viewports. The one we're looking for is this one here, and this is called Wireframe on shaded, and as I left click this, you'll notice that the wireframe appears here. I'm just going to make the perspective viewport bigger, and what I'm going to do now is I'm going to select the new primitive, I'm going to select scale, and I'm just going to begin by selecting each of these axes and scaling them along those axes. So what we're looking for to begin with is in terms of length, we want it to be just a little bit bigger than the crate itself because it's going to go diagonally. In terms of thickness, what we're looking for is something that is similar to the distance between these two edges. So we want these two edges to be roughly the same distance apart as these two edges. Although this is you know, personal preference. If you want thinner slats, by all means kind of produce thinner slats. And in terms of the depth, what we're looking for is something that's a little bit less than the extrude we've got in the crate. So I'm just going to scale this in now. And I'm going to move this up ever so slightly. Okay, so I've now got a slat. Now before I continue on, and before I worry about placing this, we have to think about optimization again. Now I mentioned this very briefly earlier when we were talking about the different kinds of platforms and the different requirements that they might have. Now although the higher end consoles and PCs can handle additional polygons in the scene, that's no excuse not to optimize as we go. Not optimizing as we go and getting into that bad habit can lead to things like the Batman Arkham Knight controversy, whereby you know, the optimization is so poor that it begins to affect gameplay. Where possible, we want to avoid this altogether. Now with this particular slat, we have to ask ourselves, once this is placed, are there going to be any polygons that we are not going to see? So once I've rotated this and I've placed it in, there are going to be several polygons that we're not going to see. There are going to be 3 in fact. I'm going to highlight them for you now. We're not going to see these 2 endpoints because they're going to be buried into the corners here. And this back polygon is going to be facing the crate. So we're not going to see them. And if we're not going to see them, but they're still there, not only do we have to unwrap them and texture them, which will take up memory, it will take up CPU, but it will take up all kinds of resources. It's also a pain in the backside. It makes unwrapping harder. And you'll notice if you've ever done any unwrapping and you find it really tough, generally speaking, the fewer objects in the scene, the fewer polygons on that object, the easier it is to kind of get your head around the unwrapping generally. So I'm going to go ahead and I'm going to delete these polygons. And I can do that by selecting them, as we just have, and deleting them by pressing the delete key on our keyboards. So now I have what looks like a row of staples. And although this looks like a pretty funny object on its own, this is going to be a much more optimized object. Now some of you are probably thinking, well, it's only 3 polygons. Well, we have 6 sides to this cube, and each side is going to have at least 1 slat. You're going to be given an option later on to kind of customize the slat design. So some of you might have 3 or 4 slats per side. And if each one of them are not optimized, the polygon count just increases and increases and increases, as does the work required to unwrap, as does the texture in memory. Everything like that increases. And over a period of time, what you end up with is a massively unoptimized object, which might not seem like a problem in itself. But if I was creating, say, Crate Simulator, and I had 300,000 crates in a scene, suddenly now we're not talking about tens or hundreds of polygons. We're potentially talking about hundreds of thousands of polygons that are being loaded into memory, have got texture applied to them, but are not actually doing anything. And even if the game performs well, which it almost definitely would do, we do have to bear in mind that things like ambient occlusion casting and many post-process effects can glitch out if we have polygons that we can't see but are still there. So it is, again, it's just best. The best thing to do is optimize as we go. So I'm going to change now to the object mode. And what I'm going to do with this is I'm going to rotate this and I'm going to place it into this crate. Now you'll notice as I switch to rotate and I begin to rotate this, that it's quite difficult for me to tell where 90 degrees is. I want this to be nice and flat. I don't want it to be a bulge, I don't want it to be twisted. So I need to know exactly where 90 degrees are. Now, one of the features of the modeling toolkit is the step snap. Now, the step snap is found at the bottom of the modeling toolkit, and you'll notice it says step snap. Currently it's off, but there's a little downwards triangle, and if I left click that, I have three options. I can keep it at off, which I don't want to do. I can change to relative, and I can also change to absolute. In this particular instance, relative and absolute will provide the same results, so I'm going to change to relative. I'm just going to left click relative. Now you notice that box is now populated with relative, and on the right hand side here I now have a number. This number represents the degree of snap. The lower the number, the more snaps you'll get. There is a temptation here just to put 90 in that and rotate by 90 degrees. But just bear in mind, if you're doing this, you're going to have to keep going backwards and changing the angle in order to kind of rotate this accurately. So I'm going to keep this at 15 degrees. Now we're going to rotate twice. Firstly, on this axis here, I want to rotate it towards me by 90 degrees. So I'm going to have a look now from the side view, and you'll notice that the snaps are much easier to control, and 90 degrees is much easier to see. And that's the first rotate operation done. Secondly, I want to rotate on this axis here, and I want to rotate 45 degrees. It doesn't matter which way you go, left or right is fine, but what I do want is 45 degrees. Once we've got that, I'm going to place this into the crate. Awesome. So now we have one slat inside the crate. Now at this point there is a temptation to duplicate this around the crate so that we end up with slats on every face. But we're not actually going to do that yet. What we are going to do in the next video is start by unwrapping this slat. Now once this slat is unwrapped, you'll have an opportunity to copy and paste it around every face, top and bottom, in any design that you like, because the unwrap will be copied with the slat. If I copied this now, I would have to select each individual slat and I would have to unwrap it separately. That pretty much concludes part 2 of this tutorial. As I mentioned earlier, the third part of this tutorial we're going to be looking at unwrapping, and we're going to start with the slat. We'll position this around the crate, and then finally we'll unwrap the crate ready for texturing. Thank you for watching.